Welcome back to your A+ hardware maintenance lesson. Trust you did well on your last assessment and have returned to a brief lesson on the electrical system. Now, the most important component of the computer's electrical system is what we call the power supply. Now, it's usually located near the rear of the computer case, and the power supply does not actually generate electricity but converts and reduces it to a voltage that the computer can handle. Now, the power supply itself will receive its power in form of 110 to 120 volts of AC or alternating current power from the wall outlet, and then it converts it to a much lower direct current or DC voltage. Older power supplies had power cables that provided either 5 or 12 volts of DC. Now, the newer power supplies provide 3.3, 5, or 12 volts of DC. In addition to providing power for the computer, the power supply runs the fan directly from the electrical output voltage to help cool the inside of the computer case. Temperatures over 185 degrees Fahrenheit or 85 degrees Celsius can cause components to fail. And when a computer is running, this and other fans inside the case and the spinning of the hard drive are the primary noisemakers of the machine. Now, a motherboard has one primary connection to receive power from the power supply. As we can see in the accompanying figure, this power is used by the motherboard and the CPU and other components that receive the power from ports and expansion slots coming off the motherboard. In addition, there might be other power connectors on the motherboard to power a small fan that cools the CPU. To power the CPU itself, or to provide additional power to expansion cards, the power supply will come with numerous other wires. Now, that concludes our brief topic on the electrical system. I'd like to move on to the instructions that are stored on the motherboard and the other circuit boards themselves. Now, there are some very basic instructions that are stored on the motherboard. Now, these are just enough to start the computer, and then use some of the simple hardware devices such as how to use a monitor and keyboard, and search for an operating system that would be stored on a storage device such as a hard drive or a CD. Now, these data and instructions are stored on a special type of ROM or read-only memory. These read-only memory chips are on the motherboard and are called the BIOS, which stands for, it's an acronym that stands for Basic Input Output System. Now, some adapter cards, such as a video card, also has their own ROM BIOS chips. And in the case of ROM chips, the distinction between hardware and software becomes quite vague. Now, most of the time, it's easy to distinguish between hardware and software. For example, a USB flash drive is hardware, but a file on the drive containing a set of instructions is software. This software file becomes called a program, and it might be stored on the drive today, but you can erase that file tomorrow and write a new one to the drive. In this case, it is clear that a flash drive is a permanent physical entity, whereas the program itself is not. Sometimes, however, hardware and software are not easy to distinguish. For instance, a ROM chip on an adapter card inside your computer has software instructions permanently etched into it during the fabrication of the card. This software is actually part of the hardware, and it is not easily changed. In this case, hardware and software are closely tied together, and it's difficult to separate the two, either physically or logically. Software embedded into hardware is often referred to as firmware because of its hybrid nature. In the accompanying figure, it shows an embedded firmware chip on a motherboard that contains the ROM BIOS programs. The motherboard ROM BIOS serves three purposes. The BIOS that is sometimes used to manage simple devices is called the system BIOS. The BIOS that is used to start the computer is called the startup BIOS, and the BIOS that is used to change some settings on the motherboard is called the BIOS setup or Cmos startup. Now, these motherboard settings are stored in a small amount of RAM located on the firmware chip, and are called Cmos Ram or just Cmos. Settings stored in Cmos Ram include such things as the current date and time, which hard drives are present, and how the parallel port is configured. When the computer is first turned on, it looks to settings in Cmos Ram to find out what hardware it should expect to find. Cmos Ram is volatile memory. When the computer is turned off, Cmos Ram is powered by a trickle of electricity from a small battery located in the motherboard or computer case, usually close to the firmware chip. If you ever wondered why your computer, which has been unplugged for a number of days, when you turn it on still knows the time, this is the reason why. This battery is necessary so that the motherboard configuration is not lost when the PC is turned off. Now, the motherboard manufacturers often publish updates for the ROM BIOS on their motherboards. If a motherboard is giving you a problem, or you want to use a new feature that was just released, you might want to upgrade the BIOS. In the past, this meant buying new ROM chips and exchanging them on the motherboard. However, ROM chips on the motherboards today are made of non-volatile memory and can be reprogrammed, called flash ROM. The software stored in these ROM chips can be overwritten by the new software that remains on the chip until it is overwritten. We'll talk more about the process of flashing a ROM when we get to Chapter 5 in our books. I would now like to direct you to the online assessment portion of this chapter in Schoology or whatever program we're using now. Then come back for a chapter summary and a lesson in key terms for vocabulary.